Hello, so we need to be able to sketch quadratic graphs. So firstly, if you have y is x squared, it's going to look like a smiley shape because the coefficient is positive. And then if you have negative x squared, it would be looking like a frowny shape, right? So it would look like that. And it will have and it'd be negative, right? So we need to consider the shape of the quadratic, if it's positive or negative, smiley or frowny. Okay, and we may need to complete the square as well to find the turning points. So here we have 2x squared, 4x, and 9. So if we complete the square on this, firstly we factor a 2 out. We get x squared at 2x, then leave the 9 outside, the number outside. Then we complete the square inside. X and a half of 2 is 1, plus 1 squared, take away 1 squared is 1, add my 9. Then I can multiply out the bracket, so I get 2 lots of x plus 1 squared, take away 2, add 9, that goes to plus 7, right? Then in part B, we now need to sketch the curve. So firstly, I can deduce that when I complete the square, the turning point is going to be when I set the bracket to 0, so x would be minus 1. Then 7 for y, okay? And then what type of graph do I have? Well, I have 2x squared. The coefficient of x squared is positive 2, which means it's going to be a smiley shape, right? Then I need to find my roots. So the roots are when I set it to 0. So the quadratic, the function 2x squared, 4x, and 9. That's set to 0. So if I use a quadratic formula, x will be minus 4 plus or minus the root of 4 squared. Take away 4 lots of 2 lots of 9 over 2 lots of 2. Then if I simplify this, I get minus 4 plus or minus root minus 56 over 4. Now this minus root is a problem. I can't have a negative in a square root. So that means it's undefined, so no real roots. So it will not cross the x-axis, okay? So now I can draw my shape, my graph. So it has a smiley shape at a turning point at minus 1, 7. So it's going to be up there somewhere. And so then my quadratic will look like this. And so then it will pass the y-axis up here. The y-intercept, that's when x is 0. So if x is 0, then that means I'll just get 9. So my y-intercept is equal to 9 there. Okay, and then my turning point is at minus 1, 7. And that's my graph. Okay. I can also sketch negative quadratics. So I have minus x squared, 6x, and 7. So firstly, I'm going to complete the square to find the turning point. So I factor a minus out to get x squared, add minus 6x, and then plus 7. So then that would be minus, if I complete the square inside, that would be x minus 3 all squared. Then take away minus 3 squared is minus 9, plus 7. And then I expand it to get minus x minus 3 all squared, plus 9, plus 7, that's plus 16, right? So therefore my turning point is going to be when they set the bracket to 0, so x would be 3, then y would be 16 at the end there. Okay, then what type of shape do I have? Well, it's negative x squared. The coefficient of x squared is negative x squared. So it's negative, which means it has a frowny shape, right? Okay, then I need to find my roots. So the roots are going to be when minus x squared, 6x, and 7 is set to 0. Solve it equal to 0. So x would be minus 6 plus or minus the root of 6 squared. Take away 4 lots of minus 1 of 7 over 2 lots of minus 1. If I solve that, I get 7 or minus 1. Okay, those are my two roots. So now I can sort of sketch my graph. Okay, so it's a frowny shape, a turning point at 316, so it's going to be up here somewhere, and then the roots at 7, should be over here, 7 and minus 1, so it's going to look, okay, and then the turning point at 316 here, okay, 16, and then the y-intercept here, well the y-intercept, that's going to be, again when x is 0, well then that's just going to get me 7, okay, so 7 there, okay. Also every quadratic curve has a line of symmetry in the middle at the turning point, right? So this is my line of symmetry at the turning point. That equation of the line of symmetry would be x is 3, line of symmetry, and there we are. Okay, and we can also work backwards, and when we're given a quadratic curve, we can find the quadratic equation, right? So here we've got the two roots at -1 and 4, so that means the factors are x plus 1, x minus 4, set to 0, okay? So my curve then, y, well, it's going to be x plus 1, x minus 4, but we have to account for the fact that there could be a scale factor. The reason being, we have to account for a numerical factor a, because if we were to solve this equation here, we could then divide by a to get x plus 1, x minus 4 equal to 0. And we've been none the wiser, right? We would still get the same roots. So we need to account for that a factor in the front there. Okay, so we need to find a then. Well, we're also given the y-intercept of -1. Okay? So that means when x is 0, y is -1, so -1 for y is going to be a lots of 0 plus 1, 0 minus 4, so that means -1 is going to be -4a, so a is a quarter. That means finally my equation is y is a quarter of x plus 1, x minus 4, and there we are. And we should expand it and we need to and then we should expand it to get it in the form of quadratic, so it'd be a quarter of x squared, take away 3x minus 4. So if we expand this, we get a quarter x squared minus 3/4 x minus 1, and that is my final quadratic equation for the curve.